Welcome to January 17th LeetCode Challenge. Flip string to monotone increasing. A binary string is monotone increasing if it consists of some number 0, possibly none, followed by some number 1, also possibly none. You're given a binary string s. Can you flip s at index I and change it from 0 to 1 or from 1 to 0? Return the minimum number of flips to make s monotone increasing. So you have a string of typically binary numbers, right? Zeros and ones, and you want to basically flip the values from 0 to 1 or 1 to 0 to make it monotone increasing, where monotone increasing is some number of zeros followed by some numbers of 1. So if we want to find the minimum number of flips as well. So we have basically 0, 0, 1, 1, 0 here, and we need to basically be able to flip one value to make this monotone increasing. So that means that we have 0, 0, and then we flip the last digit to 1, therefore we have 0, 0, 1, 1, 1, which follows monotone increasing string because it has some number of zeros followed by ones. Right, and that's the most minimum number of flips you can make to make s monotone increasing. Let's see if we were to have the following, right? We know that if we were to flip, for instance, say flip the third index, 1, 0, 1, 2, the second index to 1, and the last index to 1, then we get basically monotone increasing. However, we just flip this, flip it to basically the following. We want to flip it the first index to 0, and the last index as well, and we get this monotone increasing. So it'll be either 0 followed by all ones, or 0, 0, 0 followed by 3 ones. And it doesn't really matter the type of monotone increasing, so long as monotone increasing, and we want to do the most minimum number of flips. For this one, the most optimal way to make this monotone increasing is that we just flip it all to 0. So basically flip this to 0 and this to 0, and therefore we get all zeros, right? Because it could be zeros, possibly a number of zeros, possibly none. It would be all possibly none, no ones as well. So constraints of s, length of s is between 1 to 10 to the 5, and each index I is either 0 or 1. Okay, let's approach this question. So if a string, intuitively, if a string is monotone increasing, any of its prefixes are also monotone increasing as well. So we know that any number in the beginning is either it's gotta be 0, or any number at the end is gotta be a 1. So to make the prefix of length I monotone increasing, we can make the prefix of length I minus 1 monotone increasing, and then we want to consider to move the last character or not. So ideally, if we were to take the final results here, for example, we split it up into two parts. Say the prefix, we know the prefix itself is monotone increasing, right? So we want to determine whether we want to flip the boundary between the zeros and the 1. So that means that we want to be able to consider whether we can flip the last character or not. So this implies that we have to optimize some type of subproblem of the original question to be able to solve this. So we basically have to essentially use, it seems very characteristic of dynamic programming. So let's say that we define a dynamic programming array, which index I representing the minimum number of flips to make the prefix of length s, prefix of s of length I, so the substring of the indices, monotone increasing. We also need a base case as well, where the 0th index of the dynamic program array is 0, since empty strings will always be monotone increasing as well. Alright, so we have condition 1 being defining each index to find the prefix to make sure that the indices of the prefix of the dynamic programming array is monotone increasing. Condition 2 is to find the base case where the 0th, basically an empty substring, will always be monotone increasing. And we basically append the characters and we make it monotone increasing. So for the condition where we have to say change an index from 1 to a 0, that means that we can always append a character 1 to the end of the monotone increasing string and it's still monotonely increasing. However, if you have to change from a 0 to a 1, then we want to consider whether we need to flip it or not. So we don't flip it if the 1 is in, there's a 1 before it. Alright, if we have a 1 before, the 0, we only flip it if we could treat the case afterwards to be monotonely increasing as well. So that means we only flip the 0 right here if the result is monotone increasing. So let's just code along and we'll see how it goes. So first thing we need to do is have an answer we can return. So integer, call it answer, and that's going to be initialized to 0. We're also going to have number, and so that's equal to 0 as well. So initialize 2 variables there, and we're going to iterate through the length of s for int I equal to 0 with I less than s dot length. What we want to do is increment I for each iteration if s character at index I. So we look through each character index I. If that's equal to the character 0, then we want to determine answer to, we're going to update the answer to be, so if the character in the beginning is, we want to basically find the answer to be the minimum. So find the minimum between our number given and the answer plus 1, which is our count. Else, we can just increment our answer, our number, I should say, and then return answer here. So that means that so we let answer, the integer answer, be the final answer, and num be a number of characters of ones in the current prefix of s. The first thing we do is initialize our answer and our num to 0. For each character C, each character in the input string, if the character is equal to 1, then set num to the minimum value of num and answer plus 1. Else, otherwise, we could just increment num by 1, where we basically the number of characters of ones in the current prefix. We iterate through that in a for loop, and we just return our answer. Alright. So time complexity wise is big O of n, since the algorithm does a linear scan for the length of s. Space complexity is big O of constant space, because the algorithm doesn't really use extra space other than the integer variables themselves. Alright, that's it. Have a great day, guys.